First, one thing to remember about thin layer chromatography is that this consists of two components. One is a thin sheet that is made out of silica. Now, for the stationary phase cross-section of our silica gel, this is how it looks like, where we have the silica gel, and once you look at it in this particular region, we actually notice a couple of interesting arrangements that is going to be happening right over here, as we see a couple of repeated patterns of oxygen bonded to silica and also silica bonded to a hydroxyl, and on the other hand we have silica attached to water particles. And this is really important because this is used to enhance not only hydrogen bonding with any polar compound that is going to be coming in contact with this gel, but also oxygens here that will also enhance any potential interactions with those polar compounds. And this is how the stationary phase looks like on a silica gel. And the second thing to keep in mind about silica that is important for this chromatography is that it is known to be highly polar, and by so doing, a polar compound or a more polar compound here will be able to interact strongly with this silica gel plate. Now, the second component that is really important to be aware of is the solvent, and the solvent that is going to be eluding up, which means migrating up, is going to be considered to be a non-polar compound or combination of compounds. Now, once it's non-polar, it will interact strongly with a less polar compound, and so the less polar compound will tend to elute upwards more than polar compound, and therefore the non-polar compound, or usually solvents, ranges from the following. Popularly, people use, or scientists use, hexane, and some others they use ether, and some others they use acetone. Sometimes there are combinations of these three, and those are the things to be aware of when it comes to background understanding of thin layer chromatography. Next is labeling our silica gel plate, and to accomplish that, what we do is first we have to draw a straight line that is right at the lower section just above the solvent region, and this here is going to be important because this is where we're going to place our 3 spots, which we're going to talk about very soon. The next line that we're going to draw is just right above here our silica gel plate, and this line is where our solvent is going to elute to, that is the end level. And so eluding means it's starting from the bottom and moving to the top, focusing on our solvent. So this is something to keep in mind when it comes to drawing lines. Now, the next one here is having specific spots that are placed on the lower horizontal line, and these spots include the following. We have first to be highlighted is called the starting reactant, and this is where our specific compound that we are going to be reacting is going to be placed, and it is this particular reactant right over here. Now, the next spot here that we're going to highlight is where our reaction mixture is going to be placed, and our reaction mixture will contain not only the reactant usually, but also our products that are forming. And this is really important because you'll be able to track the progress of your reaction. As the reactants is disappearing, our products are forming usually. And the final spot that we're going to highlight here is at the center, and this here is called the core spot. The core spot is the combination of your starting reactant and your reaction mixture. And these are the three things that you need to keep in mind when it comes to labeling your specific plate. The next step here is how to read a TLC plate, and we need to read the TLC plate by one important thing, which is you must have spots that are already created. And so these spots are created due to how the solvents are moving relative to this particular silicone gel's position, not only from the lower horizontal to the higher or top horizontal line, but most importantly how the solvent not only interacts with the specific species that make up the spots, but also how the spots interacts with the silicone gel. So this is where we're going to look at two important readings to be aware of. One here is called vertical reading, and vertical reading implies the following. We're looking at the individual spots, and this column that are designated for the spot are really important because we're going to use mathematical process called the RF value, and using RF value we'll be able to determine what are the specific species of focus. And so to accomplish this, all we have to do is to divide the distance from our spot of interest to the low horizontal line, and this is divided by the distance from the low to the high horizontal lines. And those are the things to keep in mind when it comes to determining what the RF value of a spot is. And the spot includes the following. Based on the experiments that we collected and the data, we were given the following spots to be this, where here is what our reactant ended up staying after the movement, based on the starting reactant column. The next column here shows 3 spots, and this makes sense because this shows that not only do we have one species that is contained here, but also the reaction mixture species that is contained in the cold spot. And for the reaction mixture column, which is right over here, we have surprisingly 3 spots. And what does that imply? By interpreting this, we are now looking at vertical reading, where in conclusion, because this spot is present and it matches our cold spot, which is what we have right here, but the top spot and the low spot are not present in the starting reactant, this spot right here is considered to be called the starting spot, which is the starting reactant. And this is where horizontal reading comes into play. So horizontal reading enables us to match and also identify species. And here we need to be able to make the conclusion that this reaction mixture is an incomplete reaction, which means that our particular reactant is still present and they all need to be consumed in order for we to get to our final product. Our end goal is to have this spot to disappear and this spot to be left for our reaction mixture. So that is one of the things to keep in mind in here when it comes to vertical reading versus that of horizontal reading. So in this case here, all you need to do for vertical reading is use a ruler, measure the distance, for example, from here to here. And once you measure that distance, you're going to come up with a value, which is your numerator, and the denominator that is common here is from here to here. And once you have that, your n divided by your d is going to give you your specific decimal or fraction that is less than or between 0 and 1, and this value here is common for only this particular species, which is the starting material, and it must be close or equal to this particular spot right at the middle here, and also this spot right over here. Likewise, for this spot here at the top should be the same as this spot right over here in terms of the R value. And likewise, this spot at the bottom here should have the same value as this particular spot right here when it comes to the R value. The next and the second step is to be able to remember the Elude interaction chart, and this chart ranges from the following: either looking at how eluding is being addressed in terms of from fast to slow, or we look at how the interaction is done based on the plate, and this here looks at whether we have a weak to strong interaction, and therefore we have the following to remember. We know that in this case alkane has faster elution than that of any other species that you can think of, however has the weakest interaction with the plate. Next is alkene, and next is followed by our benzene group, and next is our halogen followed by our nitro, and next is our either aldehyde or our ketone group. This is followed by our alcohol group, and next is our amide, and finally here is our carboxylic acid group. And these are the things to be aware of when it comes to the chart. And so once we're able to do this, our next step, which is in this case using this chart to link to the specific species of interest in terms of the regions. And so once we have this, we can now determine what these spots are, and based on this particular chart we see that the one that interacts strongly will be at the bottom. In terms of interacting strongly with the silicone gel will be way more at the bottom and less and not at the top, and while the one that eludes faster will be at the top or higher than the spots at the bottom.